Welcome to EuCNC 2026 here in Malaga. We have a booth which is dedicated to 6G-TWIN. 6G-TWIN is a project funded by the European Commission and the Smart Network and Services joint undertaking. The idea of this project is to develop network digital twins and to integrate them into future 6G systems. So here on the booth you can see many different demos. You can see our functional architecture showcased just here with the many different models we have been working on during these 2.5 years, let's say, of the project. So we will showcase now some of the demos we have developed in the project.
In 6G-TWIN, we developed a functional architecture following the recommendations from EuCNC. We show here the different layers of the architecture, starting from the physical network, where we have the network elements that we would like to replicate by the digital domain. And in the digital domain, we have the data models that are storing the data collected from the network. Then building on that, the functional models that are application-oriented models that can do prediction, optimization, and these models can be trained, and we have the training pipeline that can be coupled by the simulation environment to train these models or to create hypothetical scenarios.
So, as we know, we have two use cases in our projects. The first one being the teleoperated driving, where we'll see some of the functional models that we developed. Starting off with the routing optimization, where we try to balance distance, latency, and bandwidth. And for this, we train a dual NDQN agent that will learn to find the best path that balances all three. As we can see here, after the training, it is integrated in a co-simulation framework where we can ask it for the start and end, and it will get us the path while avoiding the high latency zones as well as the congested links. Another example that we have is the handover optimization, for example, where if we follow the 3GPP protocol, sometimes we may fall into ping pong or RLFs, or radio link failure. So instead of waiting for the baseline procedure of waiting until hitting a certain threshold, we actually try to predict when that will happen so that we can fire off our handover early and avoid those problems like ping pong and RLF. Of course, this is integrated in the same 6G-TWIN architecture, and we can see that this actually has better results than the baseline with comparison, reducing ping pongs and radio link failures.
A crucial component of our 6G-TWIN architecture is the co-simulation framework. Now, this framework plays a crucial role. It allows us to test different network configurations and what-if scenarios in a safe digital environment. It's like a digital sandbox that allows us to find the best configuration before applying it into the real world. One very interesting feature about the simulation framework is that it integrates multiple domain-specific simulators, especially when we talk about advanced use cases such as teleoperated driving or UAV-driven logistics. We need different domain-specific simulators. So we have in this simulation framework a network simulator, a 5G simulator, a ground mobility simulator, a UAV simulator, a LEO satellite simulator, all seamlessly integrated in the same framework. And the best part about it is that it's open source to be used for the community.
For use case 2, we are focused on improving energy efficiency. So in this use case, we have 3 different scenarios. Scenario 1, for example, is talking about beamforming and risk placement. There we are using digital twins actually to speed up the sweeping of the different angles for the beamforming. And then as a second step, we are also optimizing where the RAS platform can be deployed in a given closed environment. In the second scenario, we move towards the more the energy estimation of the different cells. So, for example, if we have a cell in a given band, we can move towards another band to improve the energy consumption of the network, depending on the traffic demand and the user association, for improving the efficiency of the network using advanced sleep modes, right? And finally, in the third scenario, what we are trying is to achieve end-to-end optimization, where basically once the RAN is optimized for energy consumption, then we need to, in the edge network, let's say, we need to identify how it's going to impact the optimization on the RAN on the edge energy consumption, right? And then for that, we are using federated digital twins. So basically, we interact at a digital level instead of at a physical level.